Hi everyone, this is Jongwan. Today is April 4th, 2019. I'm gonna record this video to briefly talk about what have been done in past few weeks. So this video will break down to two parts. For the first part, I will briefly go through how to create an image that includes a customized models folder in your TaskExecutor for your data view project. And for the second part, I briefly go through the calculate covariance matrix workflow I've been working on in past 2 months and what output looks like on the AWS EC2. So let's go to the first part. Thanks by's help, we realized that the problem we cannot run our workflow on AWS in past few weeks. That is because I changed some Java files or some methods in these Java files in the model folder. And this folder will be packed into TaskExecutor that is live on the instance of AWS EC2, and through that instance we will create an image, and we use a kind of template image for every instance we launched. So that's why the old image does not recognize my new methods and new functions. So what I have to do is to create a new image based on the new models folder. So for the first part, first step we have to export this models folder as a jar file, Java jar file, and then we will import a clean TaskExecutor project into the Eclipse, and then in the build path, we will link this model jar file to our latest, just newly created one. That includes all the customized methods you've been created. So then we will export this TaskExecutor as a runnable jar file, and then we can replace this one on the instance. Any instance will launch on the EC2 by SSH the instance we have. For example, now I believe I've been wrong. I have a instance running on the AWS, and this TaskExecutor is a newly uploaded one. So after I get this one uploaded, I can create a new instance from the I can create a new image from this instance. So you can create an image, and then you're able to find that in the AMI image. In this AMI image, what you need is this ID. You will copy this one to your configure.property, because this file includes my secret keys and public keys. I won't show that in this video, but there will be an entry for the AMI ID, so you can replace that. So every time after that you launch a new instance that will use this image as a template, so you will have the method you need to execute your workflow. So that is a basic idea about how to create a new image for your TaskExecutor. And then for the second part, let's briefly go through the calculate covariance matrix workflow I've been working on for past 2 months. And let's briefly review what is the logic of this workflow. So we have a matrix, a 5x5 matrix, and we set it as an input to the task splitter, and this splitter will separate to 5 columns, and these 5 columns will calculate the covariance between every 2 of them. And actually for 5x5 matrix we only have to calculate 15, just like this, because a covariant matrix symmetric, so we only have to calculate part of half of it. So this 15 as a red index that is needed for this covariance matrix. So let's go back to the whole picture. Then after we get to 15 covariance calculate tasks down, and we aggregate them together into through a task, and then output as a covariance matrix.txt file. So let's take a look at the consoles, and here is what's the logs while executing this workflow on the EC2. And you can see there are a lot of like the covariance matrix, like the columns, separator, splitters, a lot of things. And what I want to show you is we have some files. Hold on a second. We have some files that okay, it's a little bit slow. We have some files that created in this instance while executing this workflow. So some intermediate files, just like the column splitter. Let's take a look at what's inside this kind of for example, the calculate covariance. I believe you know what's inside this column splitter. It's just a column as a vector, and in the calculate covariance task, what's the output is three numbers that is separated by the dash. You can see this is 1-4 minus 1.8, and the first two is columns and rows, and the third one is a covariance value. So that's why we remember we have this photo, and we have just for example, if we have 1 2 and 2 1, and with the value we know the covariance matrix will have this value at these 2 points. So that is a basic idea. So we get 15 outputs, and then we aggregate them together into the covariance matrix.txt. So here how it looks like. So finally we get the covariance matrix output, and well done. So far I believe we have successfully wrapped up this calculate covariance matrix workflow and successfully running on the AWS EC2 as an instance, and we also have our own new images. So that is cool. I think that is briefly what I will talk about for today, and I will keep working on some other fancy or novel workflows afterwards, and hopefully you will enjoy this video. And until next time, happy coding.